So I feel like I've gotten to the next point in the project where I feel like it is good enough to show people. So let me just show you what I've been working on. So you see we have these two arms here. We're going to take these two planks, and we're going to nail them together, which seems super simple, but actually it was not super trivial. Um, yeah, so let's just run that one more time so you get now you have a better idea of what's actually happening, because it is pretty fast. So it's going to pick up these two planks. It's going to move them into position. It's going to nail them, and then it's going to drop it off here. This is going to be the basis of another robot that I'm doing, which is basically just going to be this same setup, but it's going to be a lot more complicated. So we're going to build a birdhouse. But this obviously is sort of the start. I'm envisioning this to sort of be the roof. But that will be for a later video and a later time. So let's go through it real quickly. So we have the basic setup for all PyBullet stuff. We're gonna, load all the URDFs. We're gonna set all the joint positions, stuff like that, yada yada yada. And then we're gonna call this move to position function over and over again. You'll see actually this is this is a lot of the code. Basically, what this is going to do is going to take in the arm ID. It's going to take in a position and an orientation, and it's going to move the arm to that position, which sounds super simple, but as we saw in the last video, it's not. It can be a little complicated. The only other thing is we have these, close and open grippers, which is easy enough. And then we have the activate nail gun function, which I'll go into more depth because that's what sort of has given me the most trouble. But you can see we sort of, have this sort of, we move to grass the roofs, we close the grippers, we move it up just to avoid dragging on the floor, yeah, on and on and on. And then we're going to put it in front so we can clearly see it. So let's go into the move to position, which is, so last time we saw the angle interpolation, we'll be using that. Basically, it's just going to be an implementation of that in a function as opposed to an actual part of the program. It's going to do basically the same thing that we saw last time. The only difference is I added in this range ceiling of 1000 divided by k. That's basically to adjust the step simulation if we want to only run a couple. If we want to set k pretty low, we don't want it to step only twice because it has a larger distance to cover. I actually found that if this is set too low, it actually won't complete its motion. Which is unfortunate. Go ahead and try to set this to like 200 or something. See how it works if you want to really code for yourself, and you're gonna get a sense of how that works. Get angle interpolation we went over last time, and then the activate nail gun is where I spent a bulk of my time trying to figure it out, and honestly still have not figured it out entirely. So basically what's going to happen is it's going to check if there's contact between the nail and the thing we're trying to, the first object that we're trying to nail, in this case the sort of horizontal lying plank. We're going to create a ray, which is done by starting at the position of contact between the nail gun and the object, and then we're going to get an orientation, which is the normal of that contact point. We're going to call ray test, which is basically going to tell us what we're using it for is basically the object that it hits, which is the sort of more vertical plank, and then the position that it hits it at. That's going to be the center of our constraint. We don't actually use the hit norm, but we may at some point. So I just left it in there. So we're going to create two centers of mass. Specifically, we're going to make reference centers of mass. Because that is what the constraint requires. Unfortunately, I still haven't figured out exactly how to get these correct. This will work if the two orientations of the objects are aligned, but as we can see, they are not in this case. So I just sort of experimentally figured this out, doing, honestly, this was a lot harder than it looks. It involved me holding up pieces of paper and rotating them along with the simulation, and then it was a whole thing. This took maybe an hour. Which maybe someone smarter than me could have figured it out faster. However, that is how long it took me. But I got it eventually, and this will be a really good measuring stick for any future solutions that I come up with. Which this is I'm gonna trying to figure out this sort of reference center of mass thing is going to be my next project, or next part of the project. Um, yeah, so now that we have something to judge it against, and whether or not it is the correct answer. And then we create this constraint. Yeah, it's going to be a fixed constraint. Obviously, that does not really conform to the physical realities of how nails work. So I may change it later to a point-to-point joint. But honestly, for now, this is good enough. We just need it to work. We just need it to work once, which I'm perfectly fine with, and we will definitely change it later when we are getting to more serious stuff. But for now, this is mostly just testing, and yeah. The only other functions here are the quaternion multiply, which I don't actually use, but will hopefully be useful later. And then we have open and close gripper. This basically is, the open gripper is boring, but the close gripper is going to close using set velocity. And it's going to set the velocity until it comes into contact. And then I found that if you just leave it there, it is actually going to not grip it as tightly. So I found that I needed to get the position and then add a little bit more so it sort of presses into the planks. And also that sometimes one would contact before the other. So you have to use this sort of max position. Yeah, go ahead, look at the code, play around with it, see sort of what's up with it, and yeah, hopefully you will enjoy that. Next plan, sort of what I'm going to do is fixing this reference center of mass, and then sort of dealing with the whole orientation thing. And then from there, I'll probably start the actual, making of the birdhouse, adding in more planks, changing things up a little bit, adding in more URDFs. Yeah, so this is all a proof of concept mostly. Yeah, and then we'll go from there when that's done. My spring break is coming up, so I'll have some time to work on it. But also my senior comprehensives are due at the end of the spring break, so we'll see how much I get done. But yeah, that's it for now.